We are going to conclude chapter 7 today. So we will be ready for test 3 after today. Well, there's this little matter of studying you've still got to do, but you know how it goes. Are we surprised that in this one, the pi attacks an H, and in this one, the pi attacks a Br? In both cases, it's the less electronegative atom, isn't it? Yeah. Are we surprised the Br minus leaves with a new lone pair, and the Cl minus leaves with a new lone pair? We're not surprised at all, are we? So we're going to get a Cl minus, and we're going to get a Br minus. I'm going to need a lone pair probably. And we get on the first one, we get a carbocation. So some of you are down here and saying, wait, you forgot the third arrow. Yes, I did, but I'll get to it. There's a third arrow I missed, yeah. But I'm focusing on this one now. We got an iso group, we got a CH2 to a C to a C double C. Why is it better to put the plus charge there than on the bottom? Because that answers this question. C plus on more sub. If I write sub, they're going to ask me what it's short for. Okay, substituted. C. More hyperconj. Oh, can't leave it like that either. What's hyperconj short for? Hyperconjugation, yeah. Okay. And then we're going to get to the box. One arrow, right? Yeah. Oh, yeah. All the way to the carbon. And that gets you in the box. What does square bracket mean? What's the word for square bracket? Yeah. It means you're not finished your reaction, but it's a species that forms along the way. That's what intermediate means. Okay. Do the same mechanism again. You're getting double points. Still got a pi. Same arrows. Same arrows. New cation, same spot. This cation forms even faster than the first one, and I'm going to tell you why. I'm going to tell you why in a second. This C plus also with an H on the end, interesting, it's a silent H, also can resonate with Br lone pair. Here's a Br lone pair. I'm not going to show the resonance. I will briefly show it and erase it. Here's the resonance. Look, you can fill the octet by doing that. That is much more important than hyperconjugation. Right there. So this is the real reason why the cation's there this time, as opposed to on the bottom. You don't need the resonance in this mechanism. I am getting rid of that arrow. You just saw how it happened. So the octet violation would be fixed with resonance. That's much more important than hyperconjugation. I can't say it enough. In fact, did you know conjugation is actually a synonym for resonance? And hyperconjugation means it's related to resonance, but there's not really resonance there. It's like getting electrons close to a cation instead of moving them into a cation, moving them in being resonance. I showed that arrow. Hyperconjugation just puts them close. Sigma bond close to a cation. Anyway, that's a lot of talk about something you never have to tell me about. So you also made a Br minus when you did this reaction here. And what's the Br minus going to do the second time? Same thing it did the first time. And you're done. Pretty straightforward, huh? Good stuff. Then you're going to tell me about the third arrow I missed. And the first step in part II. What's the third arrow? I need you to tell me what pair of electrons I need to put on the page and where to put it. I need a pair of electrons to make a bond to the more substituted carbon in this step to make a triangle. The Br needs a lone pair. The atom that was attacked is the one that comes back to the more substituted triangle. That's substituted carbon, sorry, to make a triangle. And here's your triangle. You ready for a triangle? ISO, C. Still has one pi, but it's got a legitimate bond to the Br here, a legitimate bond there. These are real bonds, full bond, not partial bond. No. I used two arrows to make these two bonds. Arrows have two electrons. So there's one of the bonds made by, I guess it was made by the second arrow to the more substituted carbon. The first arrow made this bond. This third arrow made a lone pair. And what happens every time you make a triangle? What is the next step called? Backside attack on the more substituted carbon, because it's the one that spends more time with a plus charge. If you haven't memorized that statement, watch a few more videos where I say it, because it just happens every time. Okay, backside attack on the more substituted carbon. Why? Because that's the one that spends more time with a plus charge. And you get what's in the box. And you notice with an alkene, yeah, this would be an E-alkene because of the backside attack, right? Okay. Bless you. Same three arrows for the next one. Attack, leave, come back to the more substituted carbon, give me a new triangle. New triangle. ISO, CH2C. This has no more pi. It's got a new triangle with a Br in it. And it's got the old Cl on there. And it's got, yeah, and it had the old Br on there. And you made a Cl minus. Does the same thing it did before. Backside attack on the more substituted carbon, because that's the carbon that spends more time with a positive charge. Oh boy. Pretty straightforward. So that's one of our review mechanisms, really. I would say there's nothing new here except the fact you're doing it twice.